This is Akash, and today we'll study about degrees of freedom. Generally, we represent degrees of freedom with notation F. Now, the minimum number of independent variables required to define the position or motion of a system is known as degrees of freedom. For having a better understanding, let us consider a 3D space system with X, Y, and Z axes, and we consider an object in this 3D space system. Now let us see the maximum possible movement this object can have in this 3D space system. First one, this object can move along x-axis, that's positive x or negative x. That means this object have linear motion in x-axis, similarly in y-axis, and similarly in z-axis. So in 3D space, the maximum possible linear motion of this object is 3 about x, y, and z axis. Now it can have rotational motion also. So this object can rotate about x axis in yz plane. This object can also rotate about z axis in xy plane, and this object can also rotate about y-axis in xz plane. So maximum possible rotational motion this object can have in 3D space are 3. So total number of possible motion which this object can have is 6. This object have 6 maximum possible motion. Now we are studying simple mechanisms. All the motion we use in those simple mechanisms will occur in 2D space. So let's see same example for 2D space. In 2-dimensional, we have x and y axis, we have same object. Here maximum possible motion is about x-axis a linear motion, about y-axis a linear motion, and a rotational motion in xy plane. So one rotational motion and 2 linear motion we have in 2D space. So here maximum possible motion of this object we have is 3. Now let us take some examples to understand degrees of motion. I am considering a turning pair. Link 1 and link 2 are connected with a turning pair. So for calculating degrees of freedom F, we must calculate restraints. Restraints are number of those motions which are not possible. Restraints are always due to joints. So for this example, or here in this turning pair, we need to calculate number of restraints. Now the restraint motion for this turning pairs are 3 translational and 2 rotational motion. That means total number of restraints are 5. This turning pair will not allow any translation motion in any axis. Plus, this turning pair can rotate only in this plane. It cannot rotate in this plane. It cannot rotate in this plane. So 2 rotational motions are also restrained. 3 translation motions are also restrained. So total restraints motions are 5. For calculating its degree of freedom, 6 minus 5, its degree of freedom is 1. A turning pair will always have 1 degrees of freedom. Let us take one more example of that spherical joint we study in my previous lectures. Here in this spherical joints, the only allowed motion for this joint, for this knob, is rotational motion, and it can rotate in 3 dimensions. So for this motion, for this pair or this joint, linear motion is not possible. It can only rotate, and it can rotate in all the 3 dimensions. So total 3 rotational motions are there. So its degrees of freedom will be 6 minus 3, and its degrees of freedom comes out to be 3. Now one point here which should be considered is all the lower pairs will have 1 degrees of freedom. You can take any examples we studied in our previous lectures and calculate its degree of freedom. We'll get degrees of freedom to be 1 for all lower pair except this one. This is the only lower pair whose degrees of freedom is 3. So this is the main point to remember here. Now, after understanding degrees of freedom, we can easily understand about kinematic chains. If all the links are connected in such a way that the first link is connected to the last link in order to have a closed chain, and if all the relative motion in this closed chain are constrained, then such a chain will be known as kinematic chain. We'll understand this with examples. This is a fixed link, link 1, link 2, link 3, link 4. A, B, C and D are 4 turning pairs of this mechanism. Now this is the example of kinematic chain. If we consider link 2 to be input and link 4 to be output. Now let us consider here our input is in the form of rotation. This is rotating. Then link 3 will act as a coupling link or connecting link, and output is transmitted to link 4 from link 3, and we'll get rotation here also at our output at link 4. So this is the good example of kinematic chain. We have constrained motion here, and our first link is connected to the last link in such a way that it forms a closed chain. So after kinematic chain, we can also understand about mechanisms. If any one link of kinematic chain will be fixed, then we get a mechanism. Here in this example, I fix this link, and after fixing this link, I give out input and we will get output. This forms a mechanism here. We can take one more example. That is a very common example of engine. In engine we have a crank connected to fixed link, a connecting rod, This cylinder is also fixed. So crank is our link 1, connecting rod is our link 2, piston is our link 3, and fixed link is our 4. So if this is our input in rotational form, then we will get output in reciprocation form. So this kinematic chain forms a mechanism. This is mechanism and this is also mechanism. From here I can also define a machine. Machine is a combination of different mechanisms through which our desired output is obtained. There are many examples of machine. A simple lock, key and lock is a machine, or any vehicle, car, these all are machines. These all are combination of different mechanisms